Hey everyone. In this episode of ITS Now, we're going to look at the history of detection. So it's vehicle and pedestrian detection that's used with traffic systems. It actually goes back a lot further than most people realise, way back to the 1920s. So we've got a lot of interesting different things to have a look at. I'm Alistair and this is ITS Now. The earliest form of traffic signals were manually controlled by police officers. This example was installed in 1925 to control traffic at 4 junctions of Piccadilly in London, from Berkeley Street to Old Bond Street. This very sophisticated system for the time is very reminiscent of a railway signal box, with levers to control the signals. However, because the signals were manual, it meant that a police officer had to be on duty in the control hut located in the centre of St James's Street for them to operate. To overcome this, automatically controlled signals were introduced. In the UK, Prince's Square in Wolverhampton had the first experimental installation in 1927. The four-way head was suspended over the centre of the junction on a catenary wire. This was then replaced with a permanent installation in 1928 with 4 heads hung on a central pole. The modern signals at this site use old-fashioned striped poles to commemorate its significance. However, with the rapid introduction of automobiles during the 1920s, it soon became apparent that fixed-time operation of signals needed to have more flexibility. In Baltimore, Charles Adler Jr. developed the first actuated traffic signal. It operated by drivers sounding their horns to make the signals change. The system was designed to overcome frustrations at junctions on arterial routes, unnecessarily serving a side road when there wasn't any traffic waiting. This was first installed in February 1928 at the intersection of Falls Road and then Belvedere Avenue, now named Northern Parkway. Interestingly, Adler also invented the pedestrian push button. The first of these was installed in February 1929 at the intersection of Charles Street and Cold Spring Lane in Baltimore. It was the first pedestrian actuated signal. Although Adler's work demonstrated that actuated signals provided significant benefits, blaring horns was obviously a nuisance to those living nearby. To overcome this, alternatives were sought. Early variants included electrical contact strips, which shorted 2 metal strips when the weight of a car travelling over them pushed them together. However, it was found that water and dirt ingress made these unreliable. A better solution used pneumatic tubes installed into the carriageway surface to detect a vehicle driving over them. These shouldn't be confused with the modern temporary types used for traffic counts. These consisted of a slightly curved rectangular tube housed in a steel mounting that was concreted into the carriageway. These sent a burst of air pressure along the tube to an air switch located in a glass jar in the roadside chamber, producing an electrical signal that was then sent to the traffic signal controller. The first vehicle actuated site in the UK was installed in 1932 at Gracechurch Street and Cornhill in London, and within a couple of years, vehicle actuated controllers were being used widely across the country. Attempts have been made over the years to automate a range of detection requirements. This example from the 1930s shows a new pedestrian facility in Morden, Surrey, being inaugurated by Government Minister Mr. Hore Belisha Yes, they named the Belisha beacon used on zebra crossings after him. These signals used a photocell to trigger the demand when the light beam across the crossing waiting area was broken by a pedestrian. I presume that these suffered from reliability issues, which is why we don't have this type of facility now.
Please remember to click on the like and subscribe to keep updated on ITS Now.
With advances in electronics in the 1960s, inductive loop vehicle detectors were introduced. These use a coil of wire buried in the road surface, which is then connected back to a roadside cabinet. The loop emits an electromagnetic field, which is disrupted when a metal object passes over it, which is interpreted by an electronic circuit to produce a pulse to indicate the vehicle presence. Loop detectors are used for a huge range of different applications, and although the basic technology stems from the 1960s, it is still seen as a baseline which newer technologies are measured against. The 1980s saw the introduction of above-ground detection using two families of technologies, Doppler radar and passive infrared. The earlier microwave radar detectors provided capabilities to detect moving vehicles, but could not be used for presence detection, such as stop line detectors for signals, because they needed the target to be moving at least 4 or 5 miles an hour for them to be able to detect them from the background scene. Infrared detectors were then developed to provide this capability. During this era, piezo sensors were also introduced. Piezos generate a small electrical current when placed under compression, and the electrical current is proportionate to the loading they are placed under. So it's possible, therefore, to calculate the weight of an object by measuring this. These units are used for weigh in motion, or WIM for short, to determine vehicle weights while still driving on the highway. The sensors are normally long, thin units placed in a slot across each lane, with the top flush with the carriageway surface. The installation of these units needs to be highly accurate, and if not done properly, can lead to them being damaged or not reading accurately. In the early 2000s, a new in-pavement detection technology was introduced. This uses magnetometers to determine the presence of a vehicle when the magnetic field around the sensor changes. This technology typically uses a small battery-powered unit, which is installed by core drilling a hole in the surface of the carriageway. The unit is placed in the hole and then sealed in place with an epoxy resin. They communicate via a wireless link, which results in the units not having to have any cable connections to them at all. This obviates the requirements for ducts and pits for detection, which is one of the costlier elements of a new inductive loop installation. Another newer technology used for detecting stationary vehicles and pedestrians are optical detectors, and have largely replaced infrared detection. These are usually set up to respond to activity in a particular zone. This therefore improves the accuracy of the operation of the detector. However, difficulties have been experienced at sites where shadows are cast on sunny days by moving vehicles adjacent to the required zone of detection. Automatic number plate recognition systems, or ANPR for short, also referred to as automatic license plate recognition, ALPR, in the States, are used for a number of applications, including journey time information, security access control, and law enforcement requirements. For journey time information, vehicle registration numbers are detected by roadside units. The data is normally anonymized and securely transmitted to a central system. When vehicles then pass subsequent roadside units, the system can calculate a range of parameters which can be used to inform operators and the public about current road conditions. For security applications and access control, These are used to trigger automatic gates or to confirm prepaid parking, etc. They're also used by law enforcement agencies to automatically indicate vehicles which are of interest due to a vast range of parameters, such as not being taxed or insured, or if they've been associated with known criminals or incidents. Vision-based detectors use a video camera, also emerged during this period. These are generally fitted high up on a gantry or mast arm to overcome obscuration and perspective issues. The video signal is fed to a processor unit, which monitors zones that have been set up on the field of view. Due to this, they can be utilized instead of a large number of individual loop positions on a junction. The capabilities and accuracy of this technology have continued to develop over time to provide a flexible detection capability. Vision systems also offer the opportunity to alter detection zones without needing to undertake any physical works in the carriageway. Video analytics are also being increasingly used to monitor for abnormal situations. A common application is in road tunnels for detecting anomalies such as pedestrians, stopped vehicles, debris, and smoke detection. In the last decade, more advanced radar units have been introduced for applications such as motorway incident detection. These use a single verge-mounted unit to provide coverage across a motorway, instead of using two inductive loops in each lane. This vastly reduces the impact on users for maintenance activities. Thermal optical detectors have also more recently been introduced. These units have made presence detection of pedestrians more accurate because they remove issues that optical detectors could suffer from, such as shadow cast. The use of a range of sophisticated algorithms and ranging technology to improve the accuracy of detection further also provides additional capabilities for some units, such as detecting specific users, such as cyclists, from mixed traffic. Another more recent technology which has been developed monitors radio transmissions from passing equipment mounted in vehicles or carried by passengers. It is now common for vehicles to be equipped with Bluetooth systems for hands-free phone connections, and many mobile phones are permanently transmitting Wi-Fi signals in an attempt to log on to a hotspot. These can be used by traffic systems by using the unique identifying numbers in a similar way to ANPR systems to provide traffic data. The Bluetooth and Wi-Fi monitors have additional benefits in being able to monitor passing equipment for the duration of them being within range of the roadside beacon to offer an enhanced level of traffic monitoring. In recent years, an above-ground detection technology has also been introduced, which can provide a means to optimize the operation of traffic signals in response to the volume of pedestrians trying to use the crossing facilities. The Scoot Urban Traffic Control System has a capability to feed data into the system, which uses a volumetric approximation of the pedestrian demand, which can change the prioritization of pedestrian stages and the timing values associated with them. One of the most recent technologies which has been adopted for detection is scanning radar, used to identify stopped vehicles on motorways. Stopped vehicle detection, or SVD for short, tracks individual vehicle movements to identify incidents automatically. The provision of this technology has been mandated for all sections of Smart Motorway in England. So what's coming next to detection? Although the introduction of connected vehicles may do away with some of the traditional applications we've discussed, it is likely that the requirements for data will increase. So simple single parameter Internet of Things sensors could provide an increase in information granularity. Another possibility is the introduction of intelligent road studs, which might not only detect vehicles, but could also contain other sensors to measure a range of issues, such as road or structure condition, even climatic information or incident reports. So I think it's really interesting that inductive loops are still the gold standard for vehicle detection. It's what all the other technologies are measured against, their accuracy and reliability. We are going to see a lot of new technologies introduced over the next few years, and data provided by connected vehicles will have a massive impact on all the sensor capabilities and requirements that we see across the highway network. So it's going to be really interesting. We are going to see more and more sort of verge mounted detector capabilities. The use of radar is just increasing all the time. The capabilities tracking individual vehicles, identifying different types of vehicles, all sorts of things. So that's going to be really interesting to see as well. Anyway, so in coming weeks, we will be looking at a variety of different detection technology. We're working with a few different organizations around bringing you some insights to individual capabilities. So make sure you don't miss out on those. So please, if you could make sure that you subscribe to our channel, that will be greatly appreciated. Thank you to everyone who has already done so. So until next time, see you then.